Yeah, friends, welcome back. So, the idea behind this particular video is that in our last online class, I received a good number of requests on explaining the function point analysis in detail. So, I thought of covering that particular topic. Although I know that you might have covered this particular thing in your software engineering course as well, but still no issues. I mean, we people are here to support you in this tough time. So the point is that function point analysis is also a kind of metric. We use function points, and in this particular thing it's like just like your lines of code, here also we are using a kind of matrix in the form of function point. So your lines of code itself is a metric, right, to be very specific. But the problem is, or the question is, that why we need to move towards function point analysis, just because that there were certain issues with lines of code, right? Recall our one of the discussions where we said that there are some issues, right? What kind of lines to be considered, what kind of lines to be included, what kind of lines to be excluded. So they, and on top of it, there are certain shortcomings of lines of code as well. Just like these LOCs are giving us a numerical value of size, and this particular numerical value can vary widely with individual's coding style, right? So for example, I may prefer to write int a comma b comma c comma d. Someone might prefer to write int a, next line int b, and so on and so forth. Then question once again comes back to the same point: what to include and what not to include. Plus, on top of it, a good problem size measure should consider the overall complexity of the problem as well, plus the effort needed to solve it. That is, the effort needed to specify, effort needed to design, effort needed to code, or maybe the effort needed to test. All these things should also be considered, right? Complexity of the problem is something which is a major cause of concern, and on top of it, it's like this particular thing, lines of code correlates very poorly with the quality and efficiency of the code as well, because we may come across a situation where we may come up with more number of lines of code, but overall the code quality might be far better than a piece of code with lesser lines of code, right? And for that sake, there is another concept called as cyclomatic complexity that tells you how complex your code is. That came from graph theory, and there what we do is, from the piece of code we form the graphs. From the graphs we apply a formula which was there in your graph theory course as well, which is like Vg equals to E minus n plus 1, where a slight modification was done, where Vg equals to E minus n plus 2 was done. That means the complexity is edge plus E stands for edge, n stands for the number of nodes, then plus 1 and plus 2 is the minor change as per your graph theory in mathematics is concerned, and the current code complexity is concerned. But here we are talking, right now we are talking about lines of code, and so another shortcoming of this lines of code is that it penalizes the use of high level programming languages, or maybe the code reuse as well, because these kind of things, if you are implementing, then also in some sense I am not getting the accurate measure of lines of code. And on top of all these things, like measuring the lexical complexity of the program, and not giving importance to the logical or structural complexity in case of lines of code is also a major cause of concern. Plus, in large sized application, we face lot amount of difficulty to accurately estimate the lines of code as well, right? So what we see is that there are enormous number of shortcomings with your lines of code, right? So when we talk about function point analysis, what we have is that we are using function points this time, right? Function points, and this function point is nothing but a unit of measurement, and it is used to express the amount of business functionality a particular information system can provide to the set of users. And these function points are measuring the software size, right? And just because of high level of formalism, these things are accepted. These things means your function point is widely accepted in the industry. So many standards have recognized the function points, and some of these standards are like your ISO standards, where we have the Cosmic, we have SISMA, we have IFPUG, we have Mark II, we have NESMA. So all these things, like it's like well recognized, and the importance is given, a lot amount of importance is given to these function points. In this, what we do is like the most elementary process is the smallest unit of the functional user required. So that is, which is also meaningful to the end user, and it is constituting a completion of a particular transaction, right? So on top of it, then we have like several functions like data functions and transaction functions and all. In case of data functions, what we have is, we have the internal logical files and the external interface files, right? So in case of internal logical files, we have like user identifiable group of logical related data or control information that resides entirely within the application boundary. Whereas in case of external interfaces, this is the user identifiable group of logically related data or the control information which is used by the application for the reference purposes only. And then in case of your transaction functions, we have like external inputs, we have external outputs, we have some external inquiries, and so on and so forth, right? So these things we will be covering in the next few slides. So coming back to our topic, what basically this function point analysis is, that the basic purpose of it is that it is designed to estimate and measure the time, and if I am able to get the estimate of the time, I will be able to get the estimate of the cost of developing the new software applications and maintaining the existing software applications as well. That means for the new applications, I will be able to get a rough estimate of the overall budget, the time required to complete this particular project, and on top of it, for the existing applications also, I can look into the aspects that, okay, for adding a particular functionality, how much time I need, and for that sake, how much will be the total cost incurred. These function point analysis are also useful in comparing and highlighting the opportunities for productivity improvements in software development as well. That means we get to know that, okay, where are the lacunas, and we can further, look into this particular aspect and work on it. And on top of it, for various analysis for the overall productivity enhancement, this particular thing can be utilized. This FPS was given by Albrecht by IBM, who was working with IBM Corporation somewhere in the 1980s. Initially he gave in 1979, but he refined this particular function points in the year 1980s, and then it formally came into picture. So it was like in 1979 this was given and further identified and refined in the year 1980. And the main other approach used for measuring the size and therefore the time required of the software project was lines of code at that time, and which was also having good number of inherent problems, which we discussed a few minutes back, right? So I covered that particular thing a few minutes back, that there were several associated problems with this lines of code or the kilo lines of code. That's why we went ahead with this particular thing. Basically, the use of function point in place of lines of code addresses several additional issues as well, right? For example, the risk of inflation of the created lines of code, which further reduces the value of the measurement system. Plus, lines of code always reward your low level languages, because more lines of code are needed to deliver a similar amount of functionality to a higher level languages, right? So in some of the languages it's like we are writing 40 lines of code, whereas in some of the languages in just 2 or 3 lines of code we are able to get the things done. So in case of function point analysis, we have function points, like just now we had a discussion on it. So this can easily estimate the size of a software product directly from the problem specification, right? So your requirement specification document comes into picture, and it is used extensively in this particular analysis. The conceptual idea is that the size of a software is equivalent to the number of different functions or features it supports. The software product supporting many features will be of larger size, right? So it's like size of the software equivalent to the functions or the features it is supporting. So of course, more number of features, larger will be the product size. Now the question arises how this function point analysis is done. So working from the project design specification, the following system functions are measured. One is the number of inputs, the number of outputs, the number of files we talked just now, the inquiries we talked about, the interfaces, and then further what we do is that these function points are then weighed or multiplied by their degree of complexity. That means all these things, your inputs, outputs, files, inquiries and interfaces, which we are getting from the requirement specification document, are further classified into 3 categories, which is your simple, average and complex, right? So for everything we are giving some weightages. Let's say for input I am giving 3 to the simple, 4 to the average and 6 to the complex. For output it is like 4, 5, 7. For files it is like 7, 10, 15. For inquiries 3, 4, 6. For interfaces 5, 7, 10. So these values basically come from the experienced project manager who is sitting on top of the project leads or the coders, because these things are like managerial level decisions, right? Budgeting, deciding the timelines, right? So all these things are done at a higher level. So once it is done, then what we do is that let's take a simple example. Like we have 3 simple inputs, we have 4 average inputs, we have 1 complex input. Similarly for outputs I have like 6 average, 2 complex, and then 0 simple outputs. For files I have only 5 complex ones, inquiries also, and these things are further multiplied. So what we do is that based on the previous table, for all these 5 entities we are doing the classification, we are multiplying it by the weights, and then we are finding the total unadjusted function point. In this case, let's say we had 3 simple, 4 average and 1 complex inputs, and the weightage given was 2, 4 and 6. So 3 into 2, 4 into 4, 1 into 6. Similarly, the same activity is done for outputs, for files, for inquiries and for interfaces as well. So what we do is we go ahead with the unadjusted function point, which comes out to be, for in this example, as 240, and then for let's say the average case, what we are doing is the unadjusted function point is equals to number of inputs into 4, number of outputs into 5, plus number of inquiries into 4, plus number of files into 10, plus number of interfaces into 10. It's for the averaging, it's for the average case. So afterwards what we get is we come up with something called as your technical complexity factors, right? So in addition to these individually weighted function points, there are some factors that may affect the project or the system as a whole. These are called the technical complexity factors, and these are 14 in numbers. Recall our previous discussion. In our previous set of slides, I have jotted down all these 14 technical complexity factors, which affect the size of the project effort and of course time as well. And all of these are ranked from 0, which indicates there isn't any influence of this particular factor, to 6, which indicates that this is something which is essential or is strongly influencing the size and the time. Right? Some of these factors are that is high performance something which is critical in this project, or the internal processing complex, right? Whether the internal processing is complex or not. Is a system to be built in multiple sites and or by multiple organizations? Is the code designed to be reusable? Is the processing to be distributed? Or we may encounter some high transaction rates. Throughput to be considered, throughput to be considered or not, and the response time, right? Some amount of weightage to be given to the response time, and so on and so forth. So what we do is we rank all of these 14 things, 14 factors, and then what we do is that we calculate all these factors. Like complex internal processing, we have given 3. Code to be reusable, we have given 2. High performance, we have given 4. Multiple sites, we have given 3. Distributed processing, we have given 5. And project adjustment factor or the degree of influence, we have getting it to be this value, right? So that means this adjustment factor or the degree of influence is the sum of all these 5 cause of concerns which we think may affect the complexity or the size of the project or may affect the overall time. So we are getting it to be 17. Now we got the unadjusted function point, and now we are going to adjust that particular thing. So for the sake of adjustment, what we do is we multiply the unadjusted function point with the degree of influence, right? With the degree of influence. Recall this particular formula as well. This particular formula was also added when we were talking about some of these matrices. We took function point analysis, but since you people said to give an example, so I thought to come up with an example of function point analysis once again. So what we are getting is adjusted function point is equals to unadjusted function point into 0.65 plus adjustment factor into 0.01, right? So this is what we get in the form of this. So 240 into 0.65 plus 17 into 0.01. So 240 into 0.82. This is what we get, which is equals to 197 adjusted function point. So this adjusted function point is for throughout the total project. So still we are unable to calculate, because from this estimate what we are getting is that we have something called as your unadjusted function points, right? But the point was that we'll get some size, we'll get some time for completion of this particular project as well. For that sake, what we do is that so the question remains the same, that how long will the project take and how much will it cost? Time and the cost is not yet answered by function point analysis, although we were making claims that okay, we'll come up with cost, we'll come up with time. So what we do next is that we make an assumption that okay, let's assume that programmers in an organization average 18 function point per month, right? So 197 function point divided by 18 equals to 11 man months. If the average programmer is paid, let's say $5,200 per month, which includes all sorts of benefits and other extra costs, then the labor cost of the project will be 11 man months into $5,200 per month. So that would be your $57,200 will be the estimation, right? On top of it, we can further add that okay, let's take a call that okay, 30% profit to be added, 40% profit to be added, some extra costs, some miscellaneous charges to be added, and then we get the final estimate. So because function point analysis is independent of the language used plus the development platform, so it can be used to identify the product benefit of one programming language over another, right? Since it's independent of the language, we get a rough estimate for all the languages and all. That means for all the projects which we came up with the help of different languages. And one development platform over the other, that means we get some idea that okay, this particular platform was cost effective or not over a particular development platform. Then whether one development methodology works fine over another or not, so that particular thing we can get from this analysis as well. Then whether one programming department is better than the other programming department. Then before and after gains in investing in programmers training as well. And the list is not restricted to these listed here. So see, ultimately what we are getting out of this function point analysis is the estimate of the size plus the time. So from the time, what we get is we get the overall cost incurred in completing a particular project. And that's why if suppose let's say for a particular project is available in the market, so all these companies, they go ahead with these kind of estimates and then they go for bidding, right? Because in that case you need to justify that okay, this will be the overall cost which will be involved in coming up with this application. Then you need to add some overheads, you need to add some miscellaneous charges, then some percentage of the overall profit which you plan to get from a particular project. Sometimes, based on the kind of competition you face, plus if you want to add or you want to get more number of clienteles, or if you want to get a particular project that would enhance your clientele database, in that sake what you do is you go for taking a risk with minimal possible profit or margin, and then you quote it and then you try to get that particular project. So we saw that this particular function point analysis is better than your lines of code metric, and of course widely used, but still there are certain problems associated with function point analysis. This FPA still receives a good amount of criticism, just like for any other particular solution. You'll have some pros and you'll have some cons as well. So here also what we have is that this function point counts are affected by the project size. Plus once again, just like in case of your lines of code, this particular technique is not considering your algorithmic complexity, right? Once again, we are not focusing on algorithmic complexity, which was also a major drawback of lines of code, and here also we are not considering, or we are not taking your algorithmic complexity into account. Plus this FPA becomes difficult to apply to a massively distributed system, or to the system with very complex internal processing. There the estimates are not that accurate, and sometimes it becomes difficult to define logical files from the physical files, because we saw that okay, files are something which are to be considered and then further categorized as well. So this particular classification becomes tough, that okay, which is your logical file, which is your physical file. So that particular thing is also a major cause of concern. The validity of the weights that Albrecht established and the consistency of their application has been challenged. So on many occasions in past also we have observed that okay, this particular analysis fails. Then we have like different companies will calculate function points slightly different, making intercompany comparisons questionable as well, because let's say as as a manager, I may give different weights to those 14 points, someone else might give different value from 0 to 6, may give something else. Some people prefer to give values from -5 to +5 as well, so that kind of difference we may encounter. So in that case also we may come across with a situation where different function points are calculated in different companies. So that kind of situation also we may face. So this is like a typical list of typical software function oriented matrix. One is your errors per function point, that means for 1000 lines of code. We have like defects per function point. We have like cost, or the per unit function point cost in the form of dollars or rupees. Then pages of documentation per function point. Then we have like function point per person month, which can be used for the comparison. So that kind of thing we can go ahead with this function point analysis. So this is a comparative chart for comparing LOCs and function points. So what we get is like on this side we have like different programming languages. On this side we have like LOCs per function points in case of your average, median, low and high kind of situation. So these are the representative values developed by your QSM. So it's not the values which I have come up with. These are the one of the values just to showcase that what can be the actual view in when we are using these LOCs and your function point as well. So this is all we have in case of your function point analysis. I guess this particular video will help you and will clear all your doubts which you had in your last online class. So see you soon.